Okay, we're just past 9:30, so I think it's time to get started. I don't suppose I could ask somebody to close the doors at the back. Okay. Oh, thank you, Matthew. So this is session 2 this week for more instant messaging interoperability. We have quite a lot to discuss today, so let's try to get through the chair slides here. All right, first off, please note well the note well in terms of intellectual property obligations as well as code of conduct and masking policy. And in particular, I'd like to remind everyone who comes to the mic queue today, or rather everyone who makes a comment today, please do so into the microphones. And when you do so, please identify yourself clearly out of respect for everyone who's joining us remotely. Oh, yes. And of course, you must sign/scan the blue sheet, which I think happens automatically if you sort of use the on-site tool or the clipboard with the QR code that you can scan is making its way around the room. Other procedural note, we already have a note taker for today. Thank you very much, Thomas. Okay, so let's move forward into the agenda. Excuse me. All right, this was Monday, which was in the past. So today, first, we're going to hear from Raphael on the MIMI delivery service. This was bumped for Monday, so now we're going to cover it in detail. And after that, we're going to have a discussion on what do we want to do about delivery service and or transport drafts. Either adoption calls or forging a strategy for producing a document that may later be adopted. And then past that, we're going to look at some drafts on user discovery. One from what do we have here? Jonathan Rosenberg on GLaDOS, and then Giles Hogben on interoperable privacy-preserving user identity and discovery for E2EE messaging. Okay, before we move on, Rowan?
No content.
You're absolutely right, I forgot. You are on the agenda, just not on this slide. I think before user discovery, we're going to cover the updates to the content format draft from Rowan, which was adopted at IETF117. Thanks for that note, Rowan. Becker?
Yeah, this isn't quite an agenda bash, but I'm not sure where to put it, so the chair, feel free to roll me out of order. I took a quick look at the presentations from Jonathan and Giles, and they seem to start from like fairly radically different premises about what is important. So I'd really hope that people, when they start talking about their thing, would lead with what we're trying to achieve and minimize the technical details, which I'm very interested in, but not just yet. So I don't know where you have that, but if we can focus on that, it'd be helpful.
And on the delivery service and transport draft adoption stuff, we've got a couple of updates on the linearized matrix side of things based on feedback since Monday that we'd like to try to cram in, at least as part of that.
Yeah, I think that fits into the scheduled time for discussing that we have up here. Okay, last thing to note is we found out since Monday who made the stickers. Thank you so much, Lars. These are great. And if you'd like one, we have a bunch at the front. Just come and ask us after the session, and we're happy to hand some out. Okay, Jonathan, after the session. Thank you. Okay, that's that. Raphael, I think you're up. Would you like me to drive the slides for you? Mm-hmm.
Good morning. Yes, that works. All right, so we ended the session on Monday with somewhat of a heated debate about the layering and the stack, etc. So I would like to propose to take a step back from that. And so now I want to talk about the delivery service, which is something that is specific to MLS. And in order to do that, I want to set the stage a little bit. Some folks in here have been intimately involved with MLS over the past years, but not necessarily everybody. So at the risk of repeating things that you've already heard, I want to talk very briefly about what MLS actually is and what it can do. Next slide, please. So what you certainly have heard now is that MLS can do efficient end-to-end encryption in groups, but there is much more to it, which is highly relevant in the context of MIMI. So what MLS also does, it does group membership management, meaning there's a notion of a group and members get added and removed, and MLS has something to do with that. There is complete cryptographic agreement on who is in a group and who is not with MLS. That's pretty novel. That's not something we had in the past with other protocols that were end-to-end as well, but always only between two participants. So now we have this notion of a group. And not only can we agree on who is in the group, we can in fact also agree on arbitrary other data, which is relevant, for example, for the whole policy stuff. We have a mechanism called extensions for that, and we'll get back to that later. So MLS is an end-to-end encrypted protocol, which then obviously mostly involves clients. However, there's a very natural server-side component as well that comes out of MLS, and that's what we're going to talk about today in the context of the delivery service. And finally, MLS can also help you do client authentication, which will also be quite important for the DS. Next slide, please. So yeah, zooming out again, for those who are not super familiar with MLS, in the MLS architecture document, there are two rather abstract components that MLS requires as a dependency. There's an authentication service, which we're not going to talk about today, but probably very much in the future. And then there's a delivery service. So the delivery service, as I said, it's an abstract component that, as per that architecture document, is responsible for the message ordering mostly, and also for making key packages available. Next slide, please. And so a delivery service can come in two variants. One, so it's quite a mouthful. One's called consistent and partitioning tolerant, and the other one is available and partition tolerant, but only eventually consistent. So what that means is the first variant is the one we're focusing on because it's the one where the message ordering happens in real time. With the other variant, the message ordering happens eventually. So this is essentially the difference between the two. And on Monday, we already had agreement that we have this architecture with a hub. So essentially, the ordering happens on that hub. So what we propose in this document now is not just this abstract component. We want to make it much more concrete. So we clearly say the delivery service has a server-side component, and there is a delivery service protocol, which the document describes. Next slide, please. So this is, with slightly different colors, what you already saw on Monday. Thanks to Richard for that. So in this overall architecture, just as a quick reminder, we have different providers that federate. We have the concept of a room. A room is essentially a group or a conversation with different members. And we already laid out that there is one hub that is responsible for the policy enforcement, for the message ordering, etc. So that's the one on the upper right here. And there are follower servers. So the flow that is depicted here is what we also saw on Monday, and that is when a message is being sent out from one of the clients on the upper left. And so everything is in gray except for the two legs of the delivery service protocol to make it abundantly clear what the exact scope of that is. So the leg one starts with the clients and goes all the way to the hub. It tunnels through the first follower server, but since it's essentially a client-server protocol, in essence, the first follower server can inspect those messages, but they're signed by the client, so that's a very important notion. So the follower server cannot modify those messages. And then the second leg, that is what happens at fan out. So the client sends a message to the hub. The The hub is going to inspect that message, and if it's okay, it's going to fan it out to its own clients. However, that's not really relevant because that can be a completely proprietary protocol. But what's relevant is that it's going to fan it out to other providers as well. So we need a second leg from the hub to follow our servers. And that one is conceptually much easier because it's really just about forwarding messages. Most of the logic is in the leg number 1. Next slide, please. Right, so we've covered the legs. And the idea of this delivery service protocol is that it is essentially agnostic of an underlying transport protocol. So that could be HTTP, it could be XMPP, it could be matrix, linear matrix, etc. It doesn't care about that. So what the shape it has right now is that it is a request response protocol, and we use the TLS encoding to serialize that, simply because we thought that that would be the easiest solution for now. The TLS encoding means we know we have strong types in there. Everything is signed, so that's important to have a very clear binary representation of it. And it's also relatively compact and fast in encoding and decoding. Next slide, please. Right, now to the transport protocol. So the transport protocol is a little smaller in scope. So this is not between the clients anymore, so literally just between the servers. So this should not come as a surprise at all. I think this is probably what most people imagine when they think of a transport protocol. So again, we have these two legs between the first follower server to the hub as a message is being sent to the hub, and then on the next leg from the hub to the follower. So what we did there is we are proposing a draft called MIMI over HTTPS, which is really, really slim in that it just describes one endpoint for each of these legs, and takes these serialized messages, TLS encoded, takes them over HTTPS. So this is deliberately minimalistic and not substantial enough going forward. So especially what we completely left out of scope is scalability for that. But we needed a starting point. So that's where we stand today. Whereas the delivery service in terms of substance is much more comprehensive. Next slide, please. Right, so now to give you an overview of the protocol. So those who have dealt with MLS in the past will recognize this as essentially all the things you can do with MLS. I think Rowan has coined the term MLS primitives. I think it's a good one. So these are the operations you can do when you use MLS. So of course, sending messages by end-to-end encrypting them, inspecting the group membership to see who is in the group, adding, removing members, updating your own key material, joining a group. So with MLS, we have 4 different ways of doing that. That's what the MLS protocol gives you. And so with that, you can actually map that to different situations, depending on how open or closed the groups are, or if an invitation is required, etc., whatever the group policy is. And then slightly more opinionated, and that was before Rowan submitted his draft about the different kinds of groups. There was this initial consensus that we talked about in the interims before now, that we would, for a certain group type, we would like to have one-to-one connections first, and only then somebody can be added to a group afterwards. So this is where the delivery service is a little bit opinionated, and this is the part that is going to change in the sense that we ultimately need to map all these group policies once we've agreed on them for the DS to support that. The last one is quite important in my mind. So the state on clients can get corrupted, especially when you have large deployments. That just happens, bits flip, and we need a mechanism for those clients to actually resync with a group, and this is also what the delivery service protocol provides. Next slide, please. So some of the more advanced capabilities, you can have multi-device support, so more than one device per user. And importantly, we already discussed that on Monday. We can enforce policies server-side on the delivery service. And of course, clients will do that as well. We have different ways of combining the policies with MLS so that we can have instant agreement on it, and this transparency we discussed. One is extensions, but we can also do AAD, which is a way to agree on data. So the data is in the clear, so the server can actually see that. However, the server cannot modify it anymore. So it transits all the way from a client through the server to other clients. And yeah, the last one I already mentioned, this is where we are opinionated right now, but where we distinguish between one-to-one connections and groups in the future, this is going to be more elaborate, most likely. Next slide, please. Authentication. So this maybe comes as a bit of a surprise because we are now in a federated environment, and so messages go between domains. So you have traffic between domains, and that can be scary. I mean, traffic is scary, and traffic between domains is even scarier. So the question is, what can we do about that? Because we want to have something that is robust in the end. What kind of authentication can we use? And it turns out that we actually already have everything we need for authentication across domains. And that is simply the fact that in these MLS groups, clients are represented with certificates. So these certificates, they're part of what's called the ratcheting tree in MLS. So there's complete agreement on who's in the group and what certificate they have. And yeah, Ron, do you want to go first?
I just want to say that MLS has credentials, and a built-in credential type is an X509 certificate. And we can have other credential types. And for the rest of the purposes of this discussion, you can think of certificates.
I will henceforth use the term credentials. You're absolutely right, Ron. Thank you. Right. So there is public key material, to make it even more generic, we can use for that. All right, next slide, please. So same picture as before, but I deleted leg number 2. So we have the same scope here from the clients to the hub, and this is where we can do the authentication. So the clients are on a different domain, they're on a different provider, but they're also part of an MLS group on the hub. So that means that they can use their private keys to sign something and to authenticate directly to the hub. Of course, in addition, you can have additional authentication between the servers and whatnot, but it's completely orthogonal to that. Yes.
Yeah, John Peterson, clarifying question. So, I mean, is it assumed that actually it's only the clients that would have the certificates that authenticate themselves, or are there cases where the follower servers would actually possess the necessary information to authenticate who their clients are? Because there are some communication systems that have that property. So, like, is this a constraint of the architecture that the client has to be the one that holds the cert?
So this is essentially a constraint of MLS and the architecture. So MLS has this notion of client credentials that hold the private keys, and those are not to be shared with a server by design.
But the public keys are the things that would actually be used to generate the authentication information, right? We're not
yeah, absolutely. So the public keys, they can be anywhere. They're public, yes. So the hub has the public keys. Then the client produces a signature.
Just curious. Okay, so but the assumption is it's in the client always. Okay.
Right. Yeah. I mean, nobody has ever proposed anything else so far, so let's go with that.
I mean, sorry, Eric, scroll up. I mean, that certainly is the assumption, but there's no technical reason I'm aware of that you couldn't stuff it in the servers. It would just be inadvisable. I think so. I think what John is coming at is that there are a number of settings now, including telephony, where the authentication comes derives from the server. And so in these questions, it can be ported in telephony context. And it would be, as have to be like, obviously, the end-to-end guarantees would be severely weakened in the circumstances.
Richard Barnes. Yeah, I think the way you would think about like a telephony-like case here is that the follower server would effectively be acting as the clients that it is authenticating on behalf of, which which you degrade the innocent and stuff. I think another thing to keep in mind here is that it may be useful to also have server level identity as well as client identity. So I think what Raphael is talking about with the MLS credentials handles the client level identity. I think it's a question we should ask whether we also want to authenticate the services.
Yeah, that's a good point. I mean, so for the purpose of this protocol, we only talk about the client-to-server authentication. The server-to-server authentication, conceptually, I see as something that would happen at the transport layer and not the delivery service layer.
Raphael,
Yeah.
well, why don't you finish the slide? I think I have a question, but maybe I won't when you finish.
Sorry, say that again.
Yeah, why don't you finish the slide? I think I may have a question, but maybe I won't when you're done.
Yeah, so I mean, I think that's it for this slide, and the next slide is the next leg. So if you want to ask the question now, if it's has to do with that.
Yeah.
Yeah.
So I certainly agree that that the hub can technically verify the signatures. That is, it can compute them and validate they're correct. I think what's less perhaps the point I think that's also what can be done by the servers, right? The difference in the hub, I think, in this case, is it has some notion of who should be signing things, right?
Right.
So I mean, so like anybody can validate signatures, but the hub actually has a list theoretically of who should be signing things, and it ought to discard them if I'm not in the room and I'm signing stuff, right?
Yeah, exactly. So yeah, this is a good point. Maybe I should just repeat that. In my head it is obvious, but the hub, of course, has a list of who's in a group. It holds the ratchet tree. The ratchet tree again holds the credentials. So in terms of separating traffic, so say that the hub is wide open and accepts traffic from anyone. Shouldn't be standing so close to the microphone, I think. Then with that list, you can immediately know whether a request, is for a specific group and a specific client in that group, and whether that client can actually authenticate. And the rest you can simply discard. Yes, Basil.
Basil Nafuri. I guess a clarifying question: how does bootstrapping work when a group is created? Because the hub doesn't know who's in the ratchet tree.
Good point. So initially, you have to create a group on a hub. And so I guess the most vanilla version of doing that is you're only allowed to create groups on your own provider and not on somebody else's provider, although that could be up for discussion, but let's go with a simple version for now. And so this group only contains yourself, and then you add people. And as you add them, you also add their public keys to the state on the hub. So once they have received the welcome or whatever the mechanism is going to be, they can authenticate to the hub, although they've never spoken to the hub before, but the hub already knows their public key material.
Daniel Kahn-Gilmore. So let me just make explicit what I hear as one of the design choices that we have here. The hub doesn't actually appear to care what follower server a given client came from.
Yes, so that is also why on Monday I propose that the first follow server is not even that important. In theory, in the context of this protocol, clients could go directly to the hub.
Or come through some other follower server if they have some trick to do that.
And-
So in this design, I'm fine with this. I just want to make it really clear to the room that the client is associated with the room strictly by the client's credential.
Yes.
Thanks.
For the purpose of this protocol, for the transport protocol, we could make it a rule that it has to come through a specific follower server. But this protocol doesn't care about that. More questions?
Is it possible to use this with a group?
Excuse me, would you please identify yourself?
Oh, sorry, I'm Giles Hogman. Sorry, I haven't signed into the thing yet. Is it possible to use this with a group credential so that individual clients are not identified to the server, the hub server?
So you were about the metadata when they're identifying themselves, or where's that coming from?
Yeah, I mean, any communication should not be identified to a specific client if possible.
Okay, yeah, we're going to talk about metadata in a few slides. Maybe then that will answer your question. So right now, no, there is no group key material for that necessarily, in the sense that it should be a client that clearly identifies itself. also, for abuse prevention, things, rate limiting, etc. So there are good reasons why you want the client actually to be on the record there. But we have means of dissociating the client identity from a real user identity and stuff like that. So yeah, that's going to be in the next slides. Yeah. Okay.
Right. So I think that I may be a little puzzled too. So without worrying at the protocol too much for a second, I think let's just talk about like requirements. And this, I think, teasing a little discussion we had on Monday, which is, should the system as a whole be, sorry? How about that? Should the system as a whole be attempting to prevent inappropriate group joining and inappropriate message transmission at the server, at the hub location, or not? That is the key design decision. Now we can discuss exactly how it's executed, but that's the key design decision. And I think it is clearly the case that it is possible to obscure which of multiple group members is transmitting through the hub. And I think the way Giles kind of implied a minute ago with a group credential, it is clearly not the case that it's possible, and still maintain access control, so that if you and I and Rowan in our group, then Jonathan can't send to the group because he's not part of the group. But it is clearly not the case that without exposing identities to the hub, that the hub can exclude Jonathan from trying to join the group without him knowing who it is. That's just like the way it technically is, right? I think maybe to take a step back, is the general design that you're going for here one in which the hub does filter out inappropriate group joins and inappropriate message transmission, or not?
Yeah, I mean, this gives us a way to, in a minute, Ron, gives us a way to do exactly that, and I don't see why we wouldn't want to do that. Why would you allow messages that are not authenticated to pass through different domains and being forwarded? I mean,
I'm not here to advocate for that. I'm merely making sure we're all on the same page.
So we have that mechanism, and we should use it, is what I'm saying. Yeah, Rowan.
So I'm saying something a little different, which is that the protocol allows a hub server to do that. Whether the hub server engages in that behavior or not is their business. And we don't need to discuss that. It's possible. Whether it's a best current practice or whether it's a must, we can decide that later.
Okay, sure. I mean, but it seems we have some consensus that for now it seems like a good idea. We can go into the details later, yeah.
Rio Kazumara, I would like to make a clarifying question. Like, sorry if this has been mentioned, but like, what kind of what is the client signing when you say client signed the messages? Because like, I think the server does not have the keying material to like decrypt the message itself.
So I mean, so the whole protocol is a request response protocol, the ES protocol, and so the requests are being signed with a private key that corresponds to the public key that is on the hub. So the hub has this public key in clear text. There's nothing to do with encryption, and can validate these signatures. So
it does not have to do with the MLS message itself. It has to do with the request response of this protocol.
That's correct, although it is signed with the same key, yes.
Okay, thank you.
There was one other thing, Rowan, again, there's one other thing I wanted to mention here, which is I think that we should let Raphael get further through his slides before we have non-clarifying questions.
Yeah, that's a good point. Thank you. Yeah, in the spirit of timekeeping, I don't know if it's a quick one, right?
Quick follow-up. Just going back to the group credential point, I wonder if it's worth generalizing the protocol so that if the hub is willing to not manage group access, then you can join with a group credential.
Happy to look into that. As a possible extension. Yeah. Okay, next slide, please. All right, leg number 2. So this is from the hub to the follower servers, and again, we go through the internet here, so it would be nice to have authentication. And so what happens is that, so this is specifically for the fan out. And what clients can do through the first leg, they can provision on the hub whatever their own follower server needs in terms of authentication. So this is not super well defined yet because there are multiple ways of doing that. but they can provision a credential, a token, a nonce, whatever makes sense, so that at fanout, the hub can use that to authenticate to the follower servers. And that's literally the only operation that's happening here is this fanout event. So it's a lot easier. So long story short, we have authentication through two different mechanisms on both legs.
Daniel Kahn-Gilmore, sorry, I know you want to get through the slides. It seems like the client needs to also indicate which follower server needs to use these credentials for, right? So it's not just provisioning the credential, it's provisioning the destination as well.
Correct. It provisions like a whole thing, like a destination, how to authenticate to the destination. The destination, is probably going to be a domain name. It can be like a queue ID if that needs to be pushed into a queue and stuff like that.
Thanks.
Yeah. Good point. Okay, next slide. With a clarifying question?
Yeah,
okay.
This is Basil Nafori. So I guess like in case that, there is a federation behind like the messaging server. So like, for example, RCS, there's a federation there. Does every chain in that like following server have to basically authenticate or like participate in that authentication?
I mean, we have these two legs right now, right? From the clients to the hub and from the hub to the follower. These are the two legs we're considering.
Right, but if there's multiple followers on the path to the client?
So we only consider the first follower for standardization because that's what we need to agree on. Whatever you want to chain behind that is most likely just proprietary and you can do whatever you want. Okay. All right, so what state do we have on the server-side component? So we've already talked about this in essence. So we have the MLS ratcheting tree that holds the credentials. We have the group info, that's something that comes out of MLS. And then we have this information for the per client, per user authentication and message fan out, as I said. We also have key packages. We haven't talked about them yet. It's not that interesting, we just need them. It's a public key material we need. And right now we distinguish again between one-to-one connections and groups for now. Next slide, please. So what the server can do is it keeps track of who's in the group, it keeps track of the ratcheting tree, etc. So it can do all the things we discussed on Monday. It can inspect the messages, it can reject them if they don't have the right ordering, it can reject them if they don't abide by whatever policy has been set. And most importantly, it can also help new clients join, because as it sees commit coming in and it fans them out, it can update this ratcheting tree without clients having to upload the whole ratcheting tree every time someone wants to join, or every time they invite someone. So that makes the protocol pretty slim, and whenever somebody wants to join the group, they can download the ratcheting tree from the server and just become part of the group. Next slide, please. So this satisfies most of the requirements that Rowan laid out in the transport design requirements. There's some missing ones simply because that document is like only a couple of weeks old, yeah, needs more discussion, but very likely we can meet all of these requirements. Like conceptually, it's not clear that there is a particular problem with any one of them. And next slide, please. Okay, so I will talk briefly about the reduced metadata variant. So this is a variant of the protocol. So before anyone's heart rate starts to rise, this is optional, but I still want to present this briefly here. So the status quo is that most messengers don't do anything particular to avoid metadata. And oftentimes for good reasons, because they're needed for technical reasons. However, the status quo is not the state of the art. The state of the art is that what we have with Signal, where we have a fairly large deployment, I think there must be close to 100 million monthly active users by now, so it counts as something. And they do a lot to avoid metadata. So if MIMI wants to be relevant in terms of modern technology, this is not something we can completely ignore and say, okay, we'll just deal with the whole metadata thing elsewhere. So that is in essence why we propose a variant to the protocol that aims to reduce metadata essentially down to 0, depending on what metadata you look at. So we specifically focus on metadata that is stored on the delivery service, not metadata that can be observed. But if we can also reduce that, then we'll try to do that, of course. Next slide, please. So there are also non-goals. We don't want to hide identifiers like IP addresses. This is completely orthogonal. You do that with mixed nets or onion routing or whatever, not with MIMI. We also don't try to prevent statistical analysis and behavioral analysis because that's a super hard problem. Next slide, please. So the scope here is that ideally the protocol supports nearly the same functionality that we have in the other variant with the full metadata. And also supports the same security mechanism. And so this is where the complexity actually is, because you know, it's nice to not have the metadata, fine, you just don't include them, but then how do you do rate limiting? You know, how do you do abuse prevention, etc.? So the idea is to still have all of these mechanisms without needing the actual credentials and the actual identities of clients in a group. So right now, both of these variants are described in the same protocol. Next slide, please. And the mechanism is very high level because it's much more granular than that, but the idea is that the credentials and identifiers, they're replaced with pseudonyms. We have at-rest encryption at different layers, and wherever we cannot do rate limiting on the pseudonyms, we use privacy pass as a mechanism to issue privacy pass tokens that can then be redeemed, but they're limited essentially. And that way we can do rate limiting. Next slide, please. So I want to be very clear on what the downsides are for now, at least. Some of them are going to go away over time. This is conceptually very new technology, and the only large-scale deployment we have is Signal, as I said. It might be the case, depending on what kinds of groups you want to have in the end, that not all of them will be supported here. It also imposes some requirements on the transport protocol. So far, we don't really have any particular requirements for that transport protocol. And the obvious requirement here is that the transport protocol does not re-add the metadata we've just tried to strip away, obviously. We also have some requirements regarding certificates and or credentials. There is some complexity in that design, obviously. There is also complexity in the implementations. And fundamentally, this needs more analysis over time and is trickier to deploy. Simply because avoiding metadata means you need to avoid them all the time and not just once at some point in the stack. All right, next slide, please. So the path forward that we're proposing here is that we separate these two variants. We stick with the full metadata for now because that's the most generic one and most likely the one that is most useful to folks right now. We push the whole metadata minimizing variant into a separate document which has a longer timeline, and we iterate on that. Right, next slide, please. All right, so this is what a stack could look like aside from identity and credentials, which is not up for discussion right now. So the base layer is this HTTPS, MIMI over HTTPS transport protocol that is being spoken between the servers. Again, this is rudimentary right now. This is going to need more refining before we can say, okay, this is ready for production. On top of that, we have the delivery service that I just explained. Either on top of that or next to it, depending on how you look at it, we will have these group policies. So that is what Rowan proposed 2 weeks ago. This will probably need more discussion, but we have a starting point. So conceptually, without going into the details, what's being proposed, this is what the delivery service will enforce, and this is also what's then combined into the delivery service protocol. For example, at some point we have a long list of different group types. We express them as an enum. with a number for every type, and then that type is what is going to be repeated in the delivery service. But the delivery service protocol itself is agnostic of the specific type. It just has an interface to whatever is going to be defined in the group policies document. Of course, we have MLS itself, needs to be said. And on top of that, in the MLS application messages, we have the message content for which we already have a document. So this is essentially the proposed layering of that stack. Next slide, please. Same stack, but we provide an implementation as a proof of concept for that as well. So we implemented almost everything, not the group policies right now, because that is too new and not an implementation target just now. And the message content is also just partial, really, simply because it's not that important at this stage. Since we have this layering, it's completely decoupled. So we have a full stack here in that sense that allows us to do federated messaging with MLS end-to-end encryption. Going forward with group policies, right now anyone can add anyone or remove anyone from groups. And what we did is we implemented that with the reduced metadata variant simply because that was the more challenging implementation target, and we want to see if our concept actually works. The full metadata variant is, of course, easier to implement. And that would be the next step. All right, I think that was the last slide of the presentation. So now mic is open again for questions.
Just a quick question on the implementations. Are they released anywhere? I was looking on the open MLS
they're open
repo.
source, and I do not have the link on the slides, but that can be fixed
Well,
on the list.
which repo on GitHub or wherever are they? Is it in the open MLS repo? Or
No, it's on the Phoenix
okay.
organization.
Cool.
Happy to send a link around. So it's literally just a stack, and the proof of concept consists in having integration tests where Alice creates a group, Alice adds Bob, they exchange messages, they add Charlie, Charlie removes Bob, etc., this sort of thing. It's all in Rust. Yeah. Rowan, apparently you're up next.
Just as a Rowan May, just as a general comment, I just wanted to say, when Raphael first proposed the first version of this was like very, very light on details. Even then, it was, this is something that we have a charter item to do MIMI with MLS. We're going to need to explain what the implications are on clients and on hubs or servers or whatever we're calling them. And we are going to need this. We're going to need this chunk of work. So I think that the chunk of work is not controversial. I think that this is an excellent, 70, 80% of the way towards having that. And it also has, keeps the door open for the possibility for ways of doing this metadata reduction. So I think this is really very important work for this group.
Yeah, that's a good point. Thank you, Ron. So our initial intuition at the time when we didn't provide enough details for others to follow that intuition was that, eventually we're all going to end up at the same conclusion that we need something very canonical around MLS, around a delivery service, because anyone who wants to implement MLS sooner or later will arrive at that problem. How do I join with clients? Where does the key material come from, etc.? So this has the potential, of being really a canonical version of that. And I think Matthew also mentioned that when looking at linear matrix and how to plug MLS into that, the outcome was something somewhat similar.
Yeah, just to respond to that quickly, I think that's probably more for the adoption call, which I guess is in -5 seconds from now. But a quick question on your draft in general. If I remember correctly, it had an issue where if all the user's devices were to be logged out or be removed, then the user themselves is removed from the group. Is there an opportunity for a user to have, say, 0 devices, but still be considered a member of the overall room or group?
So the membership is really tied to the MLS membership. So if you don't have any clients in the MLS group, you cannot do that authentication anymore. It would be possible to have a mechanism to, have a different kind of authentication around that. And so, yeah, that would be possible. And in that instance, assuming there are still other people in the group or the group still exists, you could still rejoin the group with an external commit. That's not impossible. Like mechanically, we can do that. It's not in the draft right now. We would probably have to discuss the details and the implication and the motivation for that, etc. But something we can discuss, yes. Britta.
Britta Hale. First of all, just echoing what Rowan already said, that we need a delivery service for the MLS, which is already part of our draft. So I think this is a great way forward. Obviously, something's needed here. I do really appreciate the effort towards metadata protection. That's going to be very important to a lot of messengers. And having that option as a parallel, you have a regular, but having that option, I think is very valuable for us to be considering in this group.
Thank you. Matthew.
So I guess I wanted to second the importance of the work here in terms of defining how to use MLS for the group membership and using it as using the MLS primitives effectively like this. I guess that there is a huge concern on this in terms of not actually being applicable for the interoperability aspects of MIMI, in terms of providing a solution that messaging providers can use today or in the near future for DMA, Digital Markets Act, interoperability. And I think there may be a hybrid solution here where you can have, or you can use MLS for all the group management without going completely MLS maximalist and requiring the entire thing to be hard-coded to using MLS.
Okay, so yeah, to that point, well, I think we have a lot of substance here. So it's been mostly us working on it. And as Ron pointed out, we have maybe not been quick enough to convey what we're trying to do here. However, we have a fully specified draft today, and we have a full POC implementation as well. So the question how fast you can go with that really depends on how motivated people are.
Chair, is it okay if I throw in one last thing here?
Well, yeah, I was going to ask, are we really closing out the discussion on this draft? And then our next section is about the question that was just raised, essentially. So if you want to talk about this.
Yeah, in fact, I think my comment is a nice kind of hinge point, because I wanted to kind of highlight two things. One is that, like, the charter for this working group says that the end-to-end encryption is based on MLS. So we have a bit of an obligation to be nailed to that process-wise. And I think what my takeaway from this kind of stack that Raphael has presented and some of the discussion on Monday is that there is benefits, much like in the quick case or in the HTTPS case, to having the crypto fairly low in the stack. And I think that's a value that's worth keeping in whatever synthesis we end up adopting here. I think we do need to have some synthesis among the various proposals before we get to something that's adoptable. So I think those two values, I think, are pretty important to me, at least. I think we have some obligation to do MLS, and I think keeping the crypto fairly low in the stack is something we ought to do, like I said, based on those quick and HTTPS examples. Now, that said, I don't think that means this is we're absolutely stuck to an MLS maximalist approach. I think quick is a good example in which they are, they are focused on TLS as their crypto layer, and it's integrated, and they get a lot of interop benefit over that. But they have a formal boundary around that, and in fact have swapped out. Like they started with quick crypto, which was not TLS. They had a formal boundary around it, and when they needed to switch to TLS in the longer run, they switched to TLS. So I think we can have a focus on MLS. We can have an architecture that's built around having a security layer at a given point in the stack that we can make progress with. But we can also have some agility there in case folks want to go off book or try different things, or in case we need to change in the future.
Yeah, that's a good point. I should have said that in the beginning. So our approach here was to be as modular as possible so that things are essentially composable. So that's why we have, the transport and the delivery service as two different things. And obviously the group policy is also not baked into that. It's a standalone thing that could be used elsewhere, etc., etc. All right, thank you.
Thanks. I think kill the slides. Thanks, Raphael. What we have planned to do now, or what we had originally planned to do, was that as the chairs, we had heard in advance from both the authors of the MIMI delivery service and from Linearized Matrix that they were, potentially interested in asking for working group adoption of their drafts. This was a couple of weeks ago. And so we had, scheduled this time to talk about that. Obviously, there's been a lot of discussion since then, and interesting evolution around both the question of how different pieces of these two designs could be merged, and also the extent to which encryption is tightly integrated into the transport protocol, and how much of a dependency that implies on MLS in particular. As Richard pointed out, we do have the dependency on MLS specified in the charter. I put the charter language in the text. But of course, if anybody wants to talk about reopening the charter, that can be part of this discussion as well. So the point of the next 30 minutes is to hear views from those in the working group about what they think the best path forward is here, so that we can get to the point of having a document that we, or more than one document that we adopt that fulfills the transport and delivery service requirements. And so you're welcome to come and make any pitch you want. If you authors want to pitch your own drafts as they exist today, that's of course fine, or any other flavor that you think is the best path here. But we're trying to get a sense of the working group about what the plan should be going forward. So now's the time to do that, and the queue is open.
Hi, hi, Matthew Hodgson from Matrix. I remember to say my name for once. So first of all, I think everybody is in agreement that MLS should provide the encryption for MIMI, and it's in the charter. It's not up for debate at all. However, as I was saying, I guess at the end of Raphael's section, I'm really concerned that the interoperability piece has been forgotten here. That in the charter, it's literally interoperability first, at least chronologically, and then MLS second. Now, the reality is that the Digital Markets Act, messaging providers and gatekeepers need a solution for interoperability ASAP for March of 2024, which is less than a year away, and that needs to be implemented for billions of users in that time frame to provide one-to-one secure communication. Group comes later. And if that doesn't happen, there is going to be massive fragmentation. It's in some ways the excuse that some of the more insular gatekeepers will use in order to go and just say, hey, use our proprietary API. We're not interested in standards. There is this MIMI DS thing coming out of MIMI, which will be ready in many years. Looks amazing. It's kind of a cryptographically ideal solution, but we're not going to use that right now. So I propose that we need to have a protocol that provides a migration path, simply, from where the big players are today. And that could be using double ratchet or iMessage as cryptography or whatever it might happen to be, that needs a migration path from that to MLS. So since Monday, on the Matrix side, we've been working on linearized matrix, both as a transport and policy control, where you delegate group membership to MLS as the encryption layer, a bit in the scenario that Richard was describing in terms of Quick with its modular crypto, where you can go and pass out the group management stuff basically to MIMI DS semantics, very, very similar, if not identical, to the ones that Raphael just presented, while still critically retaining interoperability with existing group management. So you have the clients looking after the group management via MLS, but you mirror that, not in a controlling way. The ownership is still on the client side, but at least you mirror it in metadata that can be used in the transport layer that sits below it, linearized matrix in this instance, which means that people who are using linearized matrix today, like the interop demo that we showed at the hackathon with Google, can use it at the transport layer right now. And then once MLS is rolled out, and I think Google committed a few, or at least and stated their support for MLS a few days ago, there is then a migration path forwards. We've sketched this out over the last couple of days. It looks pretty positive. We've got a kind of one-pager sketch of how it could look. It's not a formal internet draft, and we critically haven't implemented it yet. Interestingly, it also supports reduced metadata via MSC 4014, which is matrix spec change proposal for pseudo IDs. Also, we've been looking at incorporating the policy requirements from Rowan's group chat policy stuff into linearized matrix in order to incorporate RBAC. And in terms of what to do about adoption, we would like to take a few more weeks at least to try to flesh this out and see if it works and propose it as a concrete hybrid between linearized matrix and MIMI-DS, rather than jumping the gun on making any final conclusions right now. And if nothing else, implement it, people can play with it and see how it feels. Sorry for the rant.
Hi, Eric Squirrel. So I think it's clear at this point that we're nowhere near ready to adopt either of these drafts. I've reviewed the linearized matrix, and I would vote against adoption, even though I think it's some good concepts, and certainly something new is coming. I don't want to adopt the linearized matrix for obvious reasons. I think there's some interesting elements in MIMI-DS, but I also don't think it's ready for adoption. I also think that like trying to hash out all the details of things in a meeting of what 60 odd people is definitely not going to work. We have two traditional mechanisms for dealing with this. One is to the proponents of the various proposals get together and try to produce a merge, and they come back with a merge. I guess three ways. Two, we do a beauty contest, which we done about May of 2024. So I think that's probably off the table. And three, we convene some kind of small design team to try to actually pull the best pieces out of each of these. So I think the question I would ask is, of the proponents of, I think it's fair to say we have like two real proposals at this point. Do they think they can get together and produce a document that is a harmonized document that they all can sign on to? And if they can, then we should let them do that and give them a little time.
What's the scope?
The scope of all the work that is on the Raphael slide. And if they can't,
the stack diagrams are
yeah.
Okay.
Like we need to tile the space. And if they can, then that's great. If they feel they can't, that's totally understandable. I've been in that situation before. Then we need some kind of design team to like actually try to hash these issues out. That's my plan on how to move forward. If you want my technical opinion on things, I'm happy to offer it, but I just don't think we're there yet.
Jonathan Rosenberg, 5'9". I mean, clearly we're not going to do a call for adoption because even the Matrix folks don't want to do it. So I'll give my. I thought he said he didn't want to do it.
Yeah, Raphael is.
Oh, Raphael wants to. Okay.
Well, no, I don't know. I'm just saying.
Okay. All right.
Sorry. You don't get to rule it out for everybody else. So I'm saying.
Okay. Fair enough. So my personal view is I like the linearized matrix view on incremental deployability. I feel this is a widely underappreciated aspect of protocol design, unfortunately, here at the IETF, where we often have a habit of defining fantastic protocols that are just not easy to roll out. And the ones that are successful are ones where we build a path forward. There are practical deadlines that Matthew has outlined, practical considerations that the gatekeepers will have in terms of meeting those deadlines. And if we have a protocol that allows us to get to MLS, maybe without starting their day one, without there being any other destination, I think we're all agreed on it. I think that's a feature, not a bug. So that's my 2 cents. Thank you.
I'm just going to ask a follow-up question now that these deadlines have been invoked twice. So there's like a March 2024 deadline.
Yeah.
What are people anticipating that we would get done? And in what state would the standards be by March 2024, if that's a relevant date for you in your thinking about this?
Who's that question to? To me?
Yeah, you just invoked the deadline. So.
And to me, it's not specifically about the deadline.
Okay.
I mean, I'm not saying that I'm saying in general, making a plea for the value of incremental deployability and a tool when you have a protocol that can be gatewayed with the existing thing without ripping out the existing thing, that's just always going to be easier to roll out. That's really my point.
Okay, thanks.
Okay. So, yeah, regarding the potential adoption of any of that. So the feedback that I received so far regarding the delivery service from pretty much all sides is that there is some agreement that this is useful and that we should have that and we should get to that. So now I also heard twice that it's not ready for adoption yet. So it would actually be nice to hear the concrete reasons why folks think that it is not ready for adoption. So far, none of that has been on the list or being provided to me. So it would be useful to hear about these reasons to see if we can actually move forward with that. And so also for that to be on the record, I disagree about the timeline problem. As I said, we have a substantial spec here for the DS. We have a proof of concept implementation of that. This is roughly equivalent with linearized matrix in that sense. So the March 2024 deadline is a difficult one anyway, regardless of what's going to happen. So I don't want to dismiss that, but I don't see why fundamentally the delivery service proposal would be more problematic than any other proposal. So yeah, and to reiterate, so please be concrete when you say that you think it's not ready for adoption yet, and what needs to be changed. Thanks.
Hi, Rowan May. So I'm going to fundamentally disagree with what Ecker said about we need to tile the space before we can do any piece and make it a working group item. If we did that in, SIP would have never finished ever. If that had been the case, we've got a list of milestones. We have a milestone specifically for the MLS delivery service. There have been comments on it that say that it's covering most of the bases. There have been no comments saying it doesn't do this wait, stop the presses, it doesn't do this horrible thing. So that's my first point. My second one is regarding this, we have a date. So Matthew invoked this deadline for one-on-one conversations and said, we have to let people go and do something easier. But we've got, I know of at least 5 MLS implementations, 2 of which are open source. We have implementation, we have implemented MLS, like lots of people have implemented this. I think this is fundamentally about if Apple doesn't want to implement MLS, why would they go and implement something else from MIMI or from the IETF? There's no credible proof that that specifically in this stated deadline that they would go implement anything else that we might try to scramble to come up with in this forum. So I think we should just completely reject that concept that because somebody's not going to be able to go in it, that they don't want to implement what we have and what already works, that we should just say, oh, we're going to give them something that they might go and implement because we think that they might. And they're not here standing up at the mic saying, hey, could you please do this thing so we could go and implement it? They're not. Thank you.
Alan Durick. So first, in favor of, oops, this one's moving, in adopting Raphael's draft. Similarly as Raphael, I didn't hear today or in any other forum really any strong reason why it should not be adopted. We are talking also about the deadlines, so also considering those deadlines, this is even speaking for it that earlier rather than later it should be adopted, and meaning now. Other thing related to making things faster by beside MLS adding support for iMessage, double ratchet. Which double ratchet? I don't see, because there is at least what I know 5 different implementations of double ratchet, and good luck they're making all of them work in a seamless way. So we're not going to make things faster by expanding the scope, especially when working against the deadline. And we learned a lot from SIP days and external requirements, and I trust we should honor some of those learnings rather than do again the same mistakes, and not only risking 24 deadline, but risking 25 deadline for the groups, which is going to be a way more important and way bigger from European Commission point of view. That's it. Thank you.
Ted Hardy, confused maximalist. I'm definitely concerned here because what I keep hearing is a philosophical difficulty underpinning where MLS goes in the stack, and an argument that if it goes in one particular place in the stack, you enable a transition from something that's relatively easy to deploy now to MLS in the future. I don't see any incentive to make that second transition. And I think in general, the problem we have here isn't a technical problem, it's an incentive problem. The whole question of whether or not these systems interoperate has never been all that technical. They always could have gatewayed. The question is really, what's the incentive for them to make this transition to use a protocol that's a general protocol for interoperability? And especially if they're going to do it once, why would they do it twice? So while I hear the argument that it might be easier to start in something that looks technically closer to one or two of the existing systems, and then make two transitions to achieve the maximalist end state, I actually don't see the incentives lining up to that in any way, shape, or form. And I appreciate the point that Jonathan was making, that it is important in some cases to allow for transitions of this type. And if there were a deep technical issue here to transition there, I would agree with him. But I think we actually have the opposite problem, which is how do you build a network effect among the cooperating systems? And that's always the interoperability question here. And I'm very concerned that if you build something with two of these transitions inherent in the plan, that you will in fact lose interoperability and therefore network effect rather than gain it. So the good news is you don't actually have to get two people with different views of where you start into a room and see if you can get them to overcome their differences, because I kind of think the charter tells you what to do here. The charter has a very strong implication that you start from MLS and not start from something that may eventually get you to MLS. I think it's possible you could read it that way if you really squinted and if there was a really big argument for it. But I think when the broader community was looking at this, their presumption was you're going to start from MLS because that's work we just finished. It's ready for this to go. So I think if you don't want to adopt a draft today, that's cool, that's fine. If you want to put people together in a room and see if they can come to a conclusion, I'm happy to do that. But I think if they can't, the answer here is actually pretty obvious.
Can you just stay there for 1 second? I don't think the charter tells us how to layer these things. Do you think it does?
I don't think it tells you how to layer them, but I do think it tells you where it's going to get the critical properties. And I think it assumes those critical properties are coming from MLS. And a design that does not get those critical properties from MLS, I believe, would have to have other advantages that were far more substantial than those which have been presented. Thank you.
Thanks.
Amandine Lepape. So I really think the standards body has duty to advance the industry. Sometimes it means look ahead and implement the future. Sometimes it means actually come up with something which is usable now to answer to an immediate needs, which is where we are at today. The key thing with the DMA coming up is that we really need a soft migration path if you really want this to be adopted, because the gatekeepers will have to do something now. So I strongly advocate for this working group to actually take the time to make sure that we are implementing something which provides this smooth migration path. And if it means push back a bit the call for adoption, then so be it. Thanks.
Thanks.
Hi, Mallory Nodal, Center for Democracy and Technology. In response to this question of the timeline, the deadline, and what are the incentives, I think it's useful to remember that in March, what's happening is the gatekeepers then self-identify and they propose to the regulatory body how they're going to implement the requirements of the DMA that is placed on them. It's not going to be code. It's going to be a description of what they propose. And why this is useful and why it doesn't need to be finalized and why actually just adopting something like Raphael has proposed here today would be enough is that it will help regulators understand, and also people who write in to try to influence the decision of the regulator. It's also, by the way, not clear if the regulator has any recourse at all to reject a proposal by a gatekeeper, but putting that aside, the actual mechanisms don't matter. The point I'm making is that there's something to compare it to. So if a gatekeeper says, well, we're just going to do an API, we're just going to wrap this in a bit of duct tape, and that's how we're going to comply with the DMA, that may not be sufficient for privacy. And then the existence of this architecture, the existence of this body working on this is enough to say, there is a better way, and we're suggesting that you try this better way. We're rejecting your proposal for how to achieve the DMA. So to that end, I think it doesn't have to be finished. It's not a race. This is enough, because if we also remember a few meetings back, we had a bunch of different competing architectures. There could have been a sort of central hub. There could have been other ways of doing this. Julia Lin's paper and others have pointed out multiple ways. And I think I'm in great support of what Raphael's put together, because I think that there's agreement on that architecture as being the best and most elegant approach to ensuring that a strong cryptographic protocol like MLS can actually be used.
Thanks. We're going to close the queue, so if you want to be in it, please join now. I don't know who's next because I lost my connection server. Ecker.
I mean, so like, thanks, Mallory, for that helpful contextualization. I mean, the like really like most optimistic possible scenario, honestly, if we were to pick something today, the most optimistic possible scenario would be that we had something like ready for like preliminary deployment in March of 2024. Like, and that would be like stunningly fast. It didn't happen that way with TLS 1.3. It didn't happen that way with Quick. You know, and like, let me point out, Quick was like a 20% of the internet, like the day that like, you know, the day that like IETF adopted it. Like, let's just, so it's pretty realistic on what it can and can't be done in the time frame we have. And so it's helpful to have Mallory's contextualization about like that we don't need to be done by that time. I guess I want to talk briefly about this sort of the point that I think Alan made a little bit earlier, which is that like there seems to be some notion people have that if we like just adopted some other cryptographic protocol or than MLS as somehow that we need deployment, and it just doesn't, because every single gatekeeper has their own idiosyncratic implementation, some which are some double ratchet variant, some which are not, and so you know, the consequence of picking one will simply be that only those people are accommodated, and the consequence of picking one of those protocols, double ratchet variant number 3 or 7 or whatever, will be those people are accommodated, everybody else is inconvenienced. And the consequence of not picking one at all will be that basically no heterogeneous group can possibly exist unless you have a multi-headed client. So there is a necessity for this to work, to have a single common cryptographic core. And I think the charter is very clear that core is MLS. And so sort of Ted was saying, attempting to have some sort of like double step thing where it's like, we're going to start by, you're going to transition only something, but it's going to be like double ratchet or iMessage or whatever. And then later with the MLS is like an incoherent technical notion in an actual deployment scenario.
Colin Jennings. I mostly came up is reacting to some of the date and deadline things from earlier on. I mean, if you adopted something today, I think you have some slim chance of still having a fairly stable spec by the time of the group deadline, and that would be good. But the enemy of this working group is time. I mean, if we miss all those deadlines and people roll out things that they need to do to meet their legal obligations, which they probably will meet, they're going to have just spent a huge expense to go do something, and they're going to be not very excited about, as Ted was pointing out, doing yet another additional rollout again. So I much more end up on you need to make this incrementally and easy to roll out to a certain degree, and we need to move quickly on this working group. Just like a huge sense of urgency in adopting things and moving forward, because that deadline's coming up so quick. And if we have nothing by those deadlines, I don't really see a huge incentive for the gatekeepers to go back after they've deployed one thing that meets the law and then go and do MIMI if it comes 5 years later. So I would encourage us to figure out how to move that quickly. Now, one of the things on that might be, well, maybe a design team could help us move that quickly. I mean, I prefer, like, some authors can get together and figure out how to do this. That's awesome. That's the best scenario possible. I'll really encourage that. But if we end up with a design team and it's operating in a fairly closed way, and it does not include, preferably more than one of the gatekeepers, which it probably won't, that's a really bad situation for me. I'd prefer to see us run an open process if the gatekeepers can only participate effectively anonymously in the process, which is currently how many of them are playing. So in trying to move fast, let's make sure that we try and get that involvement. Thanks.
Sorry, can you stay for 1 second? Can you talk about what you view as the difference between, effectively, given what we know who's participating today, the difference between the authors getting together and working on some new version of something versus a design team, which includes essentially exactly the same people?
I think the difference is maybe the standing of the output in the eyes of the working group of those two things. If a group of friends get together and do whatever they want, that's well outside the context of things. And if a group of the current drafts get together and produce something, that'd be great. I agree it's a fine line difference. If we said, like, the design team is just a group of people and whatever they bring back has no standing relative to anything else that came back, that'd be fine too. But at that point, we probably shouldn't call it a design team.
Yeah, this is Richard Barnes from Cisco. As the antepenultimate speaker in the queue, I wanted to kind of bring things back to this question of how do we get to something we can adopt. And I was going to go that design team route that Colin mentioned, because it's not really a design team, because usually design teams are working on a working group product. But it seems like getting together, Raphael and Conrad and the DS team and the linearized matrix team, it seems like we're close enough on the architectural points here that we can probably make some progress in that small group and bring something back, before the next IETF meeting for working group consideration. Now, in terms of what that should look like, let me try and sum up here, and the remaining two speakers behind me, I guess, can object, or folks can object on the list or in the Zulip. But it seems to me like I'm taking away kind of two key points from all the discussion we've had here. One, that kind of the crypto low in the stack design of the MIMI DS thing is a valuable thing to keep. And we should investigate how you can kind of make a real design that incorporates that, or more kind of complete design that incorporates that aspect. But also that the linearized matrix stuff is more real today. It's more of a complete system today. And so I think that what I would encourage a design team to focus on is basically seeing if we can reslice linearized matrix so that it has that crypto low in the stack property. And I know, like Matthew said, they've already made some progress in that, so it sounds like we've got a good start in that direction to kind of work out and refine in a small group and bring it back a proposal of the working group.
Thanks, Richard.
Basil Nafori. One of the things that kind of, I'm thinking a lot about this and hear a lot of people talking about it. One of the things that the DS proposal requires is MLS first to be deployed in order for the transport layer to be implemented, which I think maybe I'm understanding it mistakenly, but I'm happy to be corrected. And if that's kind of the case, it might make it harder for a lot of the gatekeepers to be able to parallelize the work. If we have something that is kind of a little bit more flexible that allows you to be able to work on both at the same time, because the MLS, like moving to MLS is a heavy lift, especially for an existing gatekeeper that might have like double ratchet or the iMessage implementation, and being able to kind of migrate to MLS is a very hard process, because you have to be able to do both of them at the same time, and client takes a long time to upgrade. So having that as a pre-requirement for being able to participate in interoperability means that we'll push the gatekeepers not to being able to kind of meet whatever deadlines that they would have to do, versus having something that might potentially be able to be incremental might allow us to be able to kind of get that like process working together. And it seems to me like there's a lot of disagreement about how to approach this. So I don't necessarily think an adoption today is the right path. I think we need to be able to kind of think about this, think about how like, you know, other potential gatekeepers might approach, you know, these proposals to be able to kind of get something that would actually be adopted as opposed to like stay as an RFC that is not really adopted across industry.
Thanks.
So closing out the queue here. Obviously, we need a delivery service for the MLS. That's necessary. The main point of discussion that I've been hearing so far is about interoperability. Now, both of these proposals are not going to guarantee interoperability. Right now, we have no precedence for that. Matrix has some deployed users in practice, so there's precedence for that, but that doesn't mean interoperability, certainly not by the gatekeeper applications. So to the question of should we take the time to bring together a team, a design team to figure out some emergence of these two, that doesn't mean bringing together a team for that will guarantee interoperability coming out of that. Is really about whether there's characteristics from these two different designs in terms of the properties and how they function that could be merged together to some benefit. And fundamentally, these are different designs. There's doesn't seem to be any clear path where that could be merged to have some sort of absolute property set. So in that case, and in the interest of time, and since we only have so long to get a decision made, we have one draft that's ready for a call. The other draft, the authors say it's not ready for a call. I say let's move ahead.
Pardon me. Could you, when you say let's move ahead, could you be concrete about how?
Certainly. I say go for the one where we actually have a call and we can actually get Mimi running.
Okay. So I think we have a few options here. Actually, do you think you know what the right thing to do is, Chair? Okay, I just wanted to check before I start ad-libbing. So we have obviously like widely disparate opinions about what to do. So I think we have a few options. There's been this proposal of the design team, which I think would imply we don't take any decisions today. We create this design team, they go off and do a piece of work, bring it back to the working group, and then the working group assesses what they think of that and whether whatever that produces should be adopted. We have another option, which is the linearized matrix authors have been working heartily over the last few days to do an integration with MIMI delivery service or have MLS more integrated into linearized matrix. We could give time for that new document to be produced, and then we could come back to the question of having, we'll still have two alternatives, the delivery service and the LM with DS integrated option, and we can revisit this question of adoption. If the DS authors want to do a call for adoption today, we can do the call for adoption, see what happens, or we can do these as alternative questions today in the room and say who wants to wait, who wants to do now, and assess it, try to assess consensus today. I think those are like approximately the three choices that we have. So why don't we open the queue for people to come and express their opinion about which of those options they would like to speak strongly in favor of or against.
I feel like IETF meetings are becoming like going to buy concert tickets. You like, queue opens, you click. Maybe I don't want to be first, but I want to be third. All right, I got first. I'm in favor of giving the team, the linearized matrix team, a few weeks or whatever to go produce a draft, not to do a call for adoption today. I do think it doesn't mean we have to wait till the next meeting. I know IETF does, its nature is to run that way, but we have been doing interims. We can schedule an interim to even put a deadline in place, say a month from now, we have an interim. That's where we're going to try and run a call for consensus again, see if we made progress by then. And if they haven't been able to do it, then we'll have more knowledge. I feel like we're like trying to make a decision where one of the groups has said, "Oh, I just need a little more time," and I don't think we need to do that rush. So I would wait. Thank you.
So yeah, just want to reiterate quickly what I said earlier. From our side, as authors of the delivery service, we feel that it is substantial enough and comprehensive enough to be proposed for adoption. We also have not received any specific feedback of what is missing or what is specifically problematic in there, other than the general debate about architecture, etc. So purely from an IETF perspective regarding adoption, I think this is as ready as can be. And if you have more specific input, please come forward and state it.
So you want us to do an adoption call for your draft when we close the queue?
Yeah, probably. Let's hear what folks are going to say in the queue, and then
okay.
Yeah, I'm going to speak again to that. Yeah.
Okay, I'm closing the queue, and please, if you can just very briefly state your preference between these options, that would be helpful.
Yeah, Richard Barnes-Cisco, I think JDR was pretty spot on. Let's do a design team with a deadline and have an interim in a month or 6 weeks or so. I think it would probably be good for not just to be the matrix, the linearized matrix authors involved. I think it would be good to get input from the MEDS folks, and I'd be happy to contribute. But yeah, let's do that and not take a decision today.
Hi, Rowan May. I'd like to call for adoption today. I think there's been no substantive reason not to use Raphael's document as the basis. It's been implemented, and we have reason to believe it has all the right primitives, and we can still change it as a working group document. Thank you.
Ted Hardy, I substantially agree with Rowan, and particularly I want to say that if people still want to go and make a design team to consider the issues after the adoption, we have made substantial architectural changes to other documents after adoption, and I'll point to the quick one that was raised by Richard earlier. The whole way the TLS record layer worked was changed very late in the game because there was good architectural reasons to do so. So I would say go ahead and adopt. If there is a later reason brought to the working group that justifies a change in the architecture, you can always do so. But don't stop progress now and the theory that there may eventually be something there. Thanks.
Hi, yeah, just this Mallory Nodal, Center for Democracy and Technology. Briefly agree with Ted and others to adopt and then start hashing out details if that's a design team or something else. Because I think Matthew put it really well in the chat. There are 3 options for the gatekeepers. It's either they make others speak their API. There's the second option, which is linearized matrix, something that's already been somewhat adopted and implemented. And the last thing is this maximalist approach. And I think the only out of all those 3 options, what we are doing here is the third option, because if we don't, then that third option doesn't exist.
Alan Durick. So strongly in favor of adopting Raphael's draft. As said, absolutely no reason has been brought up today that is really valid that we should not be doing it in the interest of time that everyone is bringing up. It is also that it should be adopted. Other thing when talking about the incremental approach, I do not see really a logic there how we can increment from something that has 3 different or 15 different encryption ways to do it in the next step. So good luck doing a group charts then with something what is gonna have easily I don't know how many different encryption techniques and algorithms there beside MLS.
Matthew Hodgson, Matrix. I'm strongly in favor of giving us a few more weeks to try to slice and dice linearized matrix down into different components and figure out how we can adopt the approach that Richard was suggesting of bringing the crypto as far down the stack as possible, but critically without a hard dependency on MLS. Not because the results of the working group would speak anything other than MLS, but just to provide that migration path so that people have a hope of using something now, which then basically converges on the MIMI-DS proposal. The only difference between what we're proposing today and what Raphael presented earlier is that the linearized matrix approach has that flexibility to swap out, well, not swap out the crypto layer, but at least it decouples it rather than it being completely baked in and making all the assumptions that come from the primitives that you get from MLS and depending on them uniquely. Whereas by keeping that abstraction in place, it provides the necessary on-ramp. And that's a really critical, concrete reason why we don't think that we should bet the farm right now on hard coding everything to the MLS primitives. In answer to everybody who said, I haven't heard a good reason. This is the one reason that we have two options, either the really idealistic, long-term, build everything on the MLS crypto primitives, which, no, I like for the record. In the long term, I think it's an amazing opportunity to build a decentralized, reduced metadata signal killer, but it won't solve the interoperability problem. So if we can get to the same place by two routes, surely we should do the pragmatic short-term one rather than betting the farm exclusively on the long-term one that designs out a migration path. Thank you.
Rowan, we need to move through the queue, okay? We're already deep onto the queue.
Travis Ralston, also Matrix, basically a +1 to Matthew with the, I guess, addition of a design team would also be a probable way forward for this.
Thank you. Amandine, we're going to run really quickly through the last people, so make it quick.
Amandine Lepap, so just to confirm, I'm in favor of postponing the call for adoption.
Basil Nafuri, I like Richard's idea of a design team, so I'm in favor of that.
Yeah, Vittorio Bertolo, Open Exchange. I think I'm also in favor of having the people work together. It's not conducive to a nice working environment if people are still working day and night. To have the two proposals, I think it's better for everyone if they work together and come to something which can be adopted by everyone with everyone's satisfaction.
You're killing me. You're killing me, Rowan.
Sorry. I'm saying this because it's a meta process thing, which is I'm hearing arguments that we shouldn't do this because that document is an MLS maximalist approach to the transport protocol. But that's not what his slide said. That's not what the document is. The document is when you're doing MLS, this is how you do it. It is not whether we do MLS as the only thing or not. I happen to have an opinion about that topic, but that's not what that document is, and that's not what adopting that document would be.
Okay. So I think there are a sufficient number of participants in the working group who want to do a call for adoption today. Of course, it's like a consensus call. So we're going to do a show of hands using the tool to try to assess how people feel about adopting this document today. Obviously, as I consulted with our fearless area director, and he said adoption calls are cheap. This will be one of many adoption calls we take in this working group during its lifetime. So we're going to do one today. Oh, do you want to phrase it as a question? No. Oh, well, sure you can. You can dismiss it and start it again. Yeah. It's just, I don't know. I find that it's helpful to be very clear on what the question is, right? So the question is, should we adopt the MIMI delivery service draft as a working group item in service of the associated milestone today? That's the question. Does anybody want to argue with the question? That's the question that we're putting into the poll. I can't hear you. Can you please come to the microphone?
Are you actually running the adoption call, or are you just asking if you should run one?
We're asking for the sense of the room today. Obviously, depending on what happens, we need to take it to the list to gather list feedback. But yes, this is the beginning of the adoption call starting in the room.
I apologize. I've made a mess of this.
I just want to clarify for everybody's understanding that when you say raise hand, you're saying adopt, and when you say don't raise hand, you're saying don't adopt. Just so everybody's on the same page.
Well, yeah, first we're going to wrangle the two over here.
literally know if there's a delete button or how
You don't need to delete them because like the next one, you're the only one who can see those three,
Mhm.
right?
So you're saying make a new one?
No, I see what you're saying. Yeah, I would make a new one.
Okay.
So
with
I
the-
see what happened.
So what is everyone? Okay.
But none of them are open right now.
I think so.
It's so much easier when we used to just
Can any of you currently see any of these? Okay, good. That's reassuring. Thank you. So what I'm going to do is just make a new one with the clear question with the question mark at the end, and I'm going to ask everybody who already did or did not raise their hands to do it again with apologies. All right, go for it.
And yes, so as Ecker was clarifying, if your answer to this question is yes, you should raise hand, and if your answer to this question is no, you should do not raise hand. Going once, going twice. Okay. I think you can end it. You have something to offer before we express our after. Okay. So to me, this looks like we do not have consensus to adopt this item today. That's what it looks like to me. And failing that, okay. I think it would be, well, we'll talk to the authors afterward. It did sound like people were interested in there being a design team to move forward an additional target, or for the other target to be moved forward one way or the other. So we can talk to the authors afterward about whether that's collaboratively or combatively. Is there anything else anyone wants to offer before we move on to whatever the rest of the agenda was supposed to be?
Could we pick a deadline to have this work done and be at a point where we can do another call for adoption, preferably a deadline that is sooner than the next IETF meeting?
Yeah, I mean, there's a few people in the hallway this week who had proposed trying to get back on track with our interim meeting schedule anyway. So I don't know that we want to have like a fixed deadline, but assuming we try to go back to having a call every 2 weeks, you know, maybe we give, and taking advantage of summer holidays and things, you know, maybe once we get that schedule set up, we set a target for a particular interim where we do the call for adoption, but I wouldn't really want to say what it is today. Go ahead.
Yeah, just very quickly. So as an author, we are absolutely happy to work with the design team if that's the wish of the working group. I see that as something orthogonal. It could have happened after adoption as well. And what Rowan said at the very end, I think that's very important. Adopting that document does not mean that you buy necessarily into all of the stack. It is orthogonal to a very good degree. And there is essentially no other alternative being proposed of how you could do MLS.
As an author, we are also on the Matrix side supportive of working with a design team, and thanks for the proposal of this, and also wanted to reiterate that we want to collaborate and have zero desire to be competitive about anything on this. In terms of Raphael's point just then about this is the only way you can manage group membership with MLS, totally agree with that aspect of things. However, you can architect it in a way that either completely hard code locks you to MLS and nothing else, or you can expose the metadata of I know, the policy decisions, the group membership, such that there is an on-ramp into that. Doing it in a compatible way, basically. Well, no, there's a transport draft, which is surely just going and to Ryan's point.
I apologize, but we're out of time for this. We do need to get to these user discovery drafts, and it sounds like this is what the design team will have to hash out, right?
That's a sneak preview of the discussions.
So because there hasn't been a ton of, so I think we're done. Thank you everyone for a very constructive discussion. I think there hasn't been a ton of feedback on the content format, so I would propose that we skip it and do 2 quick presentations on user discovery, unless there's something that you think you really need feedback on on the content format. Okay, sure. Yeah. Okay, so we're going to do a quick few minutes on content format and then try to get condensed presentations on discovery.
So the content format draft was adopted. There was a call. There are a couple. I encourage people to go and look at the issues that are on the slides that are posted. There were some questions on the list. I already incorporated feedback that I knew how to incorporate. The choice of message ID, this came up not this cycle, but in the previous cycle. And I made a sort of a working assumption slash proposal, which has some binding with the transport protocol. Nobody sort of had a strong objection. Nobody had an alternate proposal, but this could still change. Next slide. The sort order of messages, this has kind of come up as like a dull roar of something that's come up. Please, I have proposed a method that basically assumes that we only really care about timestamps and that we just care about timestamps being wildly wrong. There are other approaches that people use. Nobody has come forward and said, like, please go and do this instead. Exactly. There have been sort of vague suggestions about how to do that. If you have an idea about what we should do instead, please send me some text or give me an outline or like spend 15 minutes with me on a call or something like that. Next slide. If you got an idea for mentions, please send text. Next slide. We'll probably need to discuss attachments at some point. That's all I got. Thank you.
This morning, 30 minutes ago? Shit. I mean, I think I got it.
Do
Mr. Rosenberg.
Screen share again.
All right. While he's bringing it up anyway, I'll get started because I'm going to spend most of my time on the one new slide. So the discovery draft is trying to solve this problem that I think is pretty important, which is the reality that a lot of people are going to want to interconnect their messaging systems, me on iMessage, people I connect on Android messages or WhatsApp or whatever, starting from phone numbers. I don't, or email addresses, but most often phone numbers. I don't necessarily know what system those people are on. Many of the systems that are widely popular in the world use a phone number, in particular as an identifier. And I think there's a lot of value in having the ability for that to work. A user experience wherein, in order for me as a person to connect to someone on another system, I have to out-of-band interrogate them, learn what their system is, and get them to send me their UUID, whatever. I mean, I just think that's, or whatever their ID is, I think that's terrible. We're all used to a system today used by billions of people in the world where I have this thing called a phone number and I can put it in and I can message them. That is how a lot of the world works, and I'd like to preserve that ability to do that. Not that you can't connect to systems, Rowan, that don't have those things. I'm not saying we won't do that, but I do want to add support for the ability for this. So that's the problem statement I'm trying to solve. In particular, that's why I'm participating in this activity. Like, just to speak personally, I want to solve this problem. I think this is the current world's biggest interoperability for messaging problem, is this problem right here on this slide, and I'd like to solve it. And it requires this piece. Next slide. All right, so the part of the discovery problem in particular is provider one, a user types in a phone number or pulls it from their address book. How do you know what provider that user is on? And as soon as there's more than 2 such providers, this is a problem. So that's the problem we're trying to solve. Next slide. Right, so again, I made this pitch, lots of them. The biggest ones we're worried about: WhatsApp, iMessage, RCS, and SMS, all based on phone numbers. Next slide. Next slide. Next slide. I thought it was go one more. Ah, crap. I'm pretty sure this is not the new deck I sent like 30 minutes ago. So I'll just start talking to it. So the GLaDOS draft basically makes a bunch of fundamental assumptions. First, it makes this assumption that we're going to have this idea of a discovery provider. It's called a GLaDOS provider, and that there will be more than one. The 0.0 version of the draft assumed there was just one. And like I knew when I wrote that was like perhaps complete science fiction, and like, okay. And so I got rid of it in version 0.1, and now there's multiples. And the assumption is that there will be multiples because of geopolitical and organizational boundaries that introduce that requirement. So for example, I can imagine a world where there's like one in the US, there's one in the EU, maybe there's one for the RCS providers. You know, there's going to be something that is done like that. There we go. That's the one. Yeah, thank you. Good enough. Appreciate that. So there's going to be more than one, and they're going to be organized around some boundaries, and the protocol doesn't really care what defines those boundaries, but it's an 0-1 infinity problem. We have to solve it for more than one. It makes an assumption that those resolvers are trusted, and they're not trusted with everything in the world, but they're trusted to provide the mapping, and that trust is derived from some processes that would again be probably specific to the geopolitical organizational boundaries that elect or create or cause in existence these GLaDOS providers. So for example, you can imagine in the US, there's like, not dissimilar from the kind of things we did with Stir Shaken. Maybe that gets done. Maybe in RCS, the GSMA does something. I mean, I don't know, but someone will run a process and elect an entity to play this role and delegate to it a certain level of trust. So that's an assumption in this design. It's also in this assumption here that as the virtue of being a mapping service, it's okay that it knows the identifiers it's mapping, that it, from the phone number it will see, that's again the assumption in the draft, to the service independent identifier, sorry, to the service specific identifier for that thing. So I would take my phone number, my UN64, it would get mapped to, user 28 on iMessage, whatever that is. That's stored and held. But we do want to prevent the GLaDOS provider from seeing end user social graphs. So there's an abstraction where the individual end user requesting the mapping is not known, only their original provider. So we use the app providers, the WhatsApps and iMessages as intermediaries. It also makes this assumption here that the part of the design is that the resolver function is invisible to end consumers. Like there are other designs in which I, as a consumer, have to sign up with one of these GLaDOS providers, and I provide my preferences, and I register my phone numbers, and it's like another third party that I have an account on. It's trying not to do that, again, largely for barrier to entry. It says, listen, consumers have relationships with app providers. That's it. iMessages and WhatsApps and everything's going to go through that. That the app providers will include gatekeepers, but also small, potentially numerous providers. And because that it could be potentially numerous, we're going to make the assumption that some of them might be malicious, and in particular, interested in sending spam and potentially scraping this database. So the app providers are not fully trusted, and the system is meant to build in protections against somewhat malicious app providers. And so part of the role, in fact, of these GLaDOS providers, which have a higher level of trust, is to vet and check that the app providers are behaving as they ought to behave, not trying to do an enumeration attack to get out the full list of phone numbers, to generate robocalls, not trying to send too many messages. And in its position in the network, there's some ability to help, not fully stop, but help prevent those things. And I think that's goodness. So the rest sort of falls out from these assumptions. There's a query protocol. I'm not even going to bother. There's a query protocol that the app provider can go to the GLaDOS provider, map this phone number, it gets a response, and then because there's multiple GLaDOS providers, how do they exchange routing information in order to sort of limit the amount of information flow between that's stored? They exchange basically Bloom filters. Bloom filters are a really good way to sort of protect the privacy of these identities from flowing between them. There is a real-time query, so the queries would be seen between providers across geopolitical boundaries, but there's no permanent storage of data. So that's it. That's the idea behind this thing. And welcome feedback.
We'll probably want to take it on the list, unfortunately,
Do we
because
stop?
we're out of time. Yeah, we have one more
Okay,
presentation.
I'm around.
Is that okay?
Yeah.
Yeah.
Thanks for the time. Oh, and I got a sticker for participating.
So Giles, you're up.
So yeah, we're going to present the Google proposal for identity and discovery. Next slide. So requirements are very simple. Alice wants to message Bob. Alice needs to know Bob's key material and which endpoint to deliver the message to. And then the second one is if Bob has multiple clients, then you might want to receive the message on a preferred client. So that's part of the design as well. Next. But the privacy requirements here are more complicated. We want to make sure that we don't leak the social graph. So any resolver identity service shouldn't learn the user ID that the client is querying for, and obviously also the identity of the querying client and the timing of the message sent. Next. I think as the previous speaker also said, it's an explicit non-requirement that to hide the mapping between user IDs and reachability on a specific service, because that's already public information on every major service. So, next, please. So we skip that slide. So we considered 3 different architectures. I'm going to go through the ones we discounted first, real quick. Like the first idea is you just kind of brute force query. You have a baked in list of key distribution services, and you just kind of brute force query them. That's obviously doesn't work because it's expensive for the client, and even if you do it on the server side, it's too expensive. And also it leaks the private information of who you're querying to potentially to a service that you're not actually signed up for. So it doesn't work from a privacy point of view either. Next slide, please. The second option we considered and discounted is a centralized key distribution service, where I think that is basically what you were proposing. Yeah, but I think even multiple like aggregated key services, we don't think that would work, because you would have to get it's too complicated politically, basically, that you would have to get multiple providers to all cooperate, and somebody has to pay for it. And we don't think that's the best route here. Next slide. So the next the one that we have in this proposal that we've settled on is basically a DNS like model, where each provider publishes an authoritative mapping like in DNS, and then the other providers are free to replicate that or to query the authoritative mapping, and then the query is made by each client to its own front end, and crucially, we also have built in a private information retrieval protocol here that prevents any of the resolvers who didn't already know the mapping, who didn't already know the recipient from learning who you're about to contact. Next, please. So obviously I'm not going to go through all of this, but we there's basically three phases here. So you start off with defining your name server mapping, and then the requesting client front end can replicate those name records just like in DNS. And then the next phase 2, is that the client makes a private information retrieval query to the name service and gets the list of key distribution services that have identity information for that user. And then once you have that, then you query for the actual key material from the standard key distribution service that each platform already offers. And the cool thing about this is it doesn't require anybody to build a new key distribution service. Like they can use their existing key distribution service. Next slide. And then message delivery works in a similar way, that you query the name service, and then once you figured out what the supported services are for a given user, then you send to the delivery service. One point here is that the recipient, so I shouldn't say phone number, the recipient user ID is tunneled through the front end of the sender platform, because they shouldn't learn that. They don't need to learn that, and they shouldn't learn that. Next, please. And then finally, the specification of a preferred client to receive messages on. We have a proposal for that, where basically you can also register that with the name service, and it's authenticated by the same private key that you use to encrypt the messages. Next. So Femi is going to very briefly run through the private information retrieval part of this.
Thank you. So we leverage private information retrieval to protect the user social graph in a point query or a bash query setting. Next slide. So we leverage private information retrieval scheme that supports homomorphic encryptions. Basically, you are able to perform arithmetic operations on ciphertext without first decrypting it. Next slide. So how does a PIR scheme work? This is just a quick primer. You assume a database holds your record on the left, 1 to 5, and the user is interested in retrieving one of the record. In this example, the user is interested in retrieving the record 4. Next slide. So what the user will do is to represent her query as a bit string, where all the bits are 0 except at the index of interest, where it is set to 1. Then it will encrypt those individual bits and forward it as a query to the server. The server performs the server-side aspect of PIR, basically doing pairwise multiplication to get the result, and the individual product are still encrypted. The server does a summation, which is the summation of the record of interest, but the server doesn't know that that is D, and it forwards that back to the client, and the client is able to decrypt that with a private key to learn the record at that index. I think the main point here is that the server doesn't learn the record that the user retrieved, which is the index in this case, or the record or the index. Next slide, please. So next slide. So we leverage Google PIR framework, which is a new scheme that basically converts an index-based PIR into a keyword-based PIR. It does that and make existing system much more efficient. So the way this works is you first of all shard the database into smaller pieces and then do your PIR over that data. Next slide, please. So these are the cost estimates that we are looking at. So we assume the main trade-off that we make is that for a big database, we shard it into smaller pieces where it's shared as 1 million entries each. So the table on the right had the performance number we have. The first 40 megabyte is an offline download that the client needs to do. The client only needs to do it once. It doesn't do it per query. So the second upload bandwidth per query, that is the query per query cost, similarly to the download, which is 21. And the client time to compute and decrypt a response is 0.1 second. And the server, the amount of time it takes for the server on a single thread is about 1 second. So with this trade-off, we think the performance is reasonable.
Yeah, and just to be clear, that's assuming a database of 10 billion name records, so which is pretty big. I think that's it.
Thank you. I'm sorry that we had to condense this so much, but will you be putting this into an internet draft?
If you want us to, yeah.
That would be great. Yeah, if you can write it up or send whatever write-up you have to the list, and we can continue discussion on the mailing list.
Yeah, and just to say, like, we think this piece of MIMI is super critical. Like, you know, it's the very first step. You need to know how to figure out who you're communicating with. So, yeah, we're very keen on getting this adopted. Or
just a clarifying question, Daniel Gilmore. Are these figures here for querying within one shard of this set, or are they for querying across all the shards?
For one shard.
Thank you.
Yeah. Well, obviously it's parallelizable.
Matthew Hodgson, Matrix. I just wanted to echo Giles's point there that from a MIMI working group perspective, figuring out the discovery and the identity lookup problem is first of all unsolved, totally critical for the entire thing to work at all. It would be a much, much better use of our collective brains than potentially quibbling over the layering on the MLS below or above question.
Yeah, and if I could also just make one more point that I think going a little bit over and above for the privacy guarantees here is really important, because, like, you know, one press article dissing that points out critical privacy flaws here is probably enough to kill adoption. So I think, like, this may seem a little bit too maximalist, but in our experience, like, getting the trust properties of this kind of system right is absolutely critical to adoption. So that's why we're kind of going a little bit above and beyond here.
Thanks. So we're over time. We need to wrap this up. I think since we're going to get back to our interim schedule, this would be a great topic to bring back on interims. And I think we probably need some further requirements discussion as well to kind of get into exactly which of the privacy properties are we aiming at and collectively agree on those. And then we can dig into the concrete proposals. So look forward to that.
And on a less spicy note, again, there are MIMI stickers. I'm going to put them up on the table in the first row here if you'd like one.